This is Unit 2, Introducing Proportional Relationships, and this is Lesson 8, Comparing Relationships with Equations. Now remember that Lesson 7 was comparing relationships with tables. And in this first activity, patterns with rectangles, I put together a table to compare these relationships. So this continues basically from Lesson 7 into this lesson, beginning with creating a table. Now I knew that I was going to want to look at properties such as the width, the length, the perimeter. As you look at these three rectangles, you're supposed to look for patterns. And we've been studying patterns that are formed from proportional relationships. So two properties that move together through multiplication, proportional relationships. And so what are the patterns, and it's particularly related to proportional relationships, between the width, the length, the perimeter, the area? So the first thing I did was listed the width, the length, and the perimeter. And so you just look at each rectangle. So I numbered the rectangles, the width for each one of those rectangles, the length for each one of those rectangles, and the perimeter for each one of those rectangles. So now we can begin to look at the area for each of those rectangles. And that is the length of the side, the length of the width times the length. So the area is the width times the length, and actually you can just count the little squares, but you can see that it's 1 times 3, or 2 times 6, or 3 times 9. All right, so what's the relationship between the width and just the number of the rectangle? Not the greatest thing to look at, but it's a place to start. So then in that case, the width is the length of the number of the rectangle. So if it's rectangle number 1, the width is 1. Rectangle number 2, the width is 2. Rectangle number 3, the width is 3. On the other hand, the length is 3 times the number of the rectangle. And this is where you can look at the relationship between the width and the length. You can see that the length is also 3 times the width, which is a better relationship to look at. So if the width is 1, the length is 3. If the width is 2, the length is 6. And if the width is 3, the length is 9. So the length is 3 times the width. So the length is 3 times the width in each case. 3 times the width, 3 times the width, and 3 times the width. What's the relationship of the width to the perimeter? And in that case, you can see that it is 1/8. If you look at 1 unit for the side width here, the width along the side, you can see that that's 1 out of 8 of those units. So 1, 2, 3, 4, 5, 6, 7, 8. So the width is 1/8. If you double the width, and then you also double the length, double the width on this side, double the length on this side, so this length of the width, 2 units here, is still going to be 1/8 of the total perimeter all the way around. And the same thing will happen if you multiply the width times 3, or if you triple the width. You're going to triple the lengths, triple this width. So this width is going to be 1/8 of the perimeter all the way around. So it's 1, 2, 3, 4, 5, 6, 7, 8. But look what happens when you compare the width to the area. So the width right here to the area right here. So for rectangle number 1, it's 1/3. For rectangle number 2, it is 2/12 or 1/6. For rectangle number 3, it's 3/27 or 1/9. So this relationship changes, and this tells you that the relationship between the width and the area is not a proportional relationship. It's not constant. It changes. There's no constant width per unit area, per 1 unit area, for example. So this number changes. So it's not a proportional relationship. Now what happens if we use a rectangle with a width of 10 units? With a length, it's going to be 3 times as long, so that's proportional. You multiply the width by 10, then you're going to multiply the length by 10. The perimeter is also proportional. The perimeter is 8 times as long, so it's 80 of, compared to a width of 10. And the area, on the other hand, is a number other than, it's not 30, it's not 10 times 3, it's something other than that. Oh, it's 100 times 3. So it's 100 times, if you multiply the width times 10, the area increases by 100 times. So that's clearly not a proportional relationship. If you finish this out, the width to the rectangle number is still 1. The length to the rectangle number is still 3. 3 times 10 is 30. But the width to the perimeter is still 1/8. So this width is 1/8 of this perimeter. 10 over 80 is the same as 1/8. But the width to the area is 1/30. 10 over 300 is 1/30. Again, not a proportional relationship. So just getting you used to, first of all, creating tables and looking for proportional relationships within those different properties or between those different properties. So we're always looking at 2 properties at a time and asking the question, do they form a constant relationship? Are they proportional?